Hello, everyone. Welcome to this webinar. My name is Nikhil Pillai, and I'm the Regional Chairman of YRP in the West Midlands region. I'm also a PhD student at the University of Birmingham working on railway infrastructure engineering. For those of you who do not know about the YRP, I believe a lot of you are YRP members, but there are also people who are not YRP members. For them, YRP are an organization who believe in promoting, inspiring, and developing the next generation of railway professionals. For this, we host a lot of different networking and development events. And the event that we are hosting today is a talk on the future of railway signaling systems. And we are joined today by Mr. Peter Harbottle, who is a senior engineer at Atkins. Thank you very much, Peter, for joining us today.
No, thank you.
No worries. So regarding the format of today's event, after this quick introduction, we'll hear from Peter about the future of railway signaling systems, and followed by that, we'll have a Q&A session. So with the Q&A session, you'll have to type your questions in a question box that you can see on your screen. So on the right-hand side of your screen, you'll see a small tab inside which you'll have a question box. So please type your questions in there and send them over to me, and I'll read them out to Peter after his presentation, and then we'll go from there. So thank you very much, Peter. I'll hand over to you now, and I'll disappear and see you when it is question time. Thank you.
That's great, thank you. So today I'm going to talk about the future of railway signalling systems, and particularly how Atkins are applying their Atkins signalling method to major re-signalling schemes and level crossing renewals across the UK railway infrastructure. So I'll be talking a bit about Atkins and the SNC Lavalin group, who sort of now own Atkins Rail and the rest of Atkins. I will then be talking about the sort of strategic rail business, along particularly with the signalling and communications business, for which I'm part of. I'll do a bit of an overview of my career and what projects I've worked on since I started with Atkins. I'll talk a bit about the ASM and Atkins signalling method, what we're doing, why we're doing it, and obviously the sort of the attendees here. Not everyone has a signalling background. Not everyone knows in detail about what a re-signalling scheme is necessarily. So I'll talk a bit about a railway signalling system, the overview, and what an interlocking is. I'll then go into the Electrologics Product, which is the heart of our signalling offer, and talk a bit about the architecture of that, along with the sort of Atkins signalling method, i.e. our way of doing a re-signalling scheme, and how we've sort of produced templated design for that. I'll then talk a bit about the key achievements we've had over the last few years with the actual ASM, and then I'll talk a bit about the future sort of project pipeline and what's coming next from a development perspective. I'll then close with any questions. So Atkins is a global, fully integrated professional services and project management company. Our vision is to strive to be the premier engineering solutions partner, committed to deliver complex projects from vision to reality for a sustainable lifespan. So Atkins was acquired by the SNC Lavalin Group on the 3rd of July 2017. Joining forces meant we now have 50,000 employees worldwide, people speaking 70 languages, offices in over 50 countries, and over 130 nationalities of people. So it's a big boost on the sort of initial Atkins headcount, which I believe was about 20,000 prior to the acquisition. We sort of provide a enhanced value-added chain, including consultancy and advisory, design and engineering, construction and project management, and then into operations and maintenance. So that's sort of one of the key messages about the sort of two organisations joining up. We've managed to sort of broaden our sort of sector influence. And Atkins is part of the SNC Lavalin engineering, design and project management sector. The sort of focus of the EDPM organisation is aerospace, defence, education, environment, infrastructure design, transportation and water. From a railway perspective, the strategic rail market is embedded within the transportation business. Our sort of key clients include Network Rail, High Speed 2, Transport for London, various design and build contractors where we'll provide detailed design offering to them. Some of our services include consultancy, engineering design, including civils, mechanical and electrical, permanent way, and signalling and communications, for which I'll be spending most of the talk talking about. The signalling and communications business provides many sort of services within this sector, including scheme development, so the sort of from sort of concept level to outline design, which is network rail grip stages 1 to 4. We also provide design and build services, which is group 5 to 8, mainly for re-signalling schemes, life extension projects, and standalone level crossing renewals. As part of the wrong side failures contract with Network Rail we have a technical investigation centre, which provides investigation services into wrong side failures, among other services. We also do touch on ETCS consultancy for the sort of ETCS rollout both in the UK and abroad. As well as sort of the emphasis being on the sort of signalling side, we also provide a lot of telecoms only services, including station projects or SISS renewals. We also provide a lot of secondees into the Network Rail telecoms business. So in terms of my sort of career with Atkins, I graduated from York University in July 2008 with a degree in electronic engineering. I commenced employment with Atkins in September 2008. I didn't really have any desire to go into the railway business. I didn't really know that much about the railway industry, but the job was sort of offered to me in Atkins via a sort of university careers fair, and I joined and started sort of as an assistant engineer, later promoted to a design engineer, and then latterly senior engineer. So the railway has really given me a sort of good career path in terms of promotions and opportunities, which I then sort of utilised to attain chartered engineer status in November 2017 with the Institute of Engineering and Technology. Sort of previous roles carried out to date with Atkins have been sort of telecoms designer, telecoms independent checker for designs. I currently act as a contractors responsible engineer, CRE, for the telecoms discipline on many multidisciplinary projects. And also I'm technical authority for the Atkins signalling method for the network, that's the IP network and the telecoms elements of our offering. In addition to that, I provide mentorship and guidance to graduate and apprentice engineers as and when required. I'm notionally based in York, in normal circumstances anyway, but a lot of travel to London, Birmingham, Croydon and Crewe is involved in my sort of role. In terms of projects that I've worked on over the years with Atkins, when I started, I've just been awarded a very large design and build contract for re-signalling the North London line as part of the enabling works for the Olympic Games. So that was a great project to start on because it was a major project. It allowed me to sort of gain technical knowledge in railway telecoms, including design, site surveys, construction and test support, and project engineering. I managed to then consolidate that sort of knowledge on the subsequent project, which was the Stourbridge Hartlebury re-signalling scheme. So it was good to actually start on that scheme with some knowledge rather than learning everything on the job. Moving on to the next project I was involved in was the Farnham area signalling renewal scheme, again a GRIP 5 to 8 design and build project. And that project was great because it allowed me to actually undertake a lot of the CRE duties with the guidance of the sort of nominated CRE. But I got a lot more exposure to client meetings and sort of interfacing with other disciplines and taking a lead role. I then started work for a few months up in Glasgow on the Edinburgh-Glasgow Improvements Project, which was all around the electrification of the Edinburgh to Glasgow line. We were introducing new technology on that line, which was the sort of voice over IP telephones. So that was a great introduction to how to introduce new technology onto the railway, which is very rightly so reticent sometimes of sort of jumping in and introducing new technologies straight away. The project which I've been working on for the last 7 years now is the Feltham and Wokingham area resignaling scheme. So I've seen that all the way from grip 2 through to grip 5 to 8 on the first phase of the project. And that's been really good to actually see a full project from sort of concept to completion in terms of the first phase. I'm now looking at sort of leading the subsequent phases of the project, which run through the sort of control period 6. Also, the Feltham scheme was the first introduction of the Atkins signalling method on the UK railway, which I will talk about shortly. So just to give a bit of an idea of what we're doing in terms of sort of IP-based future signalling systems, we're continuing the rollout of a new interlocking technology for the UK rail network, which is the Alstom Electrologics. Initially, back in 2013, we started talks with Alstom, who were at the time GE. They weren't a big player in the UK market from an implementation perspective. They provided products for other suppliers, and their product, Electrologics, was seen as a good fit for the sort of UK railway network. We then produced a delivery process, mapped it out, and that developed into the Atkins signalling method. Hardware development started using EN 50126 principles, and the first application of the Atkins signalling method was due to be a standalone level crossing, but this soon changed. So the reasons Atkins wanted to get involved in the introduction of new interlocking was to sort of remove the reliance on competitors such as Siemens or Alstom interlocking products. This would give us an increased competitive advantage. The Electrologics interlocking also rationalises and reduces quantity of trackside cabling, which is saving money and then decreasing sort of civils costs. Again, with the sort of standardisation of equipment and lower number of trackside equipment location cases, that also helps. This all sort of boils into significant capex and opex savings across the whole project life cycle. Another sort of key selling point of our Electrologics interlocking technology is that there is no reliance on bespoke software languages which are being used in previous interlocking technologies such as SSI. The system is future-proof, scalable, and ETCS compatible. Just for those of you who are not that familiar with the sort of key components of a signalling system, I produced a very simple diagram. I'm not a signalling engineer myself, comms obviously, but I'll do a brief introduction to this. So the key elements of a system are the train detection, which could be axle counters or track circuits, to detect where trains are on the railway network. We then also have line side signals, which you will all be familiar with. We then have a control system, which is located within a signalling centre, and that's operated by the signaller. We then also trackside have points, which allow movement of trains between lines at crossovers and junctions. All of this is controlled and monitored via the interlocking, which is the heart of the signalling system. So in terms of what an interlocking is, it is an arrangement of signal apparatus that prevents conflicting movements through an arrangement of tracks such as junctions or crossings. The interlocking is designed so that it's impossible to display a signal to proceed unless the route to be used is proven safe. Essentially, it stops or prevents trains crashing through the use of the signalling system. There's several types of interlocking that have been developed over the years. Initially, mechanical interlockings, which we show here with the lever frames. That then advanced through to electromechanical interlockings, where elements of the system were replaced by electrical relays and contacts. There was then full relay interlocking systems, so an example is in the middle picture here. We've then moved through to sort of more computer-based and electronic systems such as SSI, Westlock and SmartLock, where SSI dates back to the 1980s, so is now old technology. We're now looking at implementing PLC-based interlockings such as Electrologics and Westtrace. In terms of just an overview of the Electrologics product itself, it's manufactured by Alstom. It's known as a vital logic controller. It uses IP communications to talk to adjacent devices. So IP, Internet Protocol technology, being at the heart of the system architecture. The system allows advanced diagnostics via what we call a scalable remote condition monitoring system, which improves maintainability. Initial product acceptance is to cover the interlocking application and level crossing controller applications, both of which we've implemented on the UK railways so far. One of the sort of selling points is a common hardware platform between trackside equipment and control center equipment. So we have different sizes of kit, but it can be used in different scenarios. We then provide a dedicated signaling network known as the multi-service network, MSN, and this provides connectivity between all Electrologics chassis as required. I've just done a brief diagram really showing the sort of range of equipment that we actually connect together for the signaling system. I've talked quite a bit about the fact that we use the Electrologics interlocking product, but really that is only part of our sort of signaling offer. We use a lot of other equipment to form the full signaling system. So we've got examples would be train detection kits such as the Frauscher axle counters. We use devices called RSTIs for condition monitoring of power supplies and points. We also use XNet decoders and encoders for CCTV level crossings. The sort of common theme though is that everything is connected via an IP network rather than providing bespoke cabling and links for different devices. So it really does cut down on the infrastructure required. The actual multi-service network, which connects everything together, as I mentioned, there's a wide range of equipment. I think I mentioned most of them on the last slide. The only other thing to mention is the control system, so signaler's system, either an Alstom MCS or a Resonate IECC is connected. Also, in addition to that, we're developing voice over IP telephony, so for SPTs, to be connected via the system, and this is for the East West Rail 2 project initially. The pictures here just show some of the examples of network switches that are used in the system, and they are commercial off-the-shelf products that you'd probably see in other industries across the world as well. From an architecture perspective, we link all signaling location cases together via trackside fiber cabling, shown linking the devices here. We then provide network switches within each signaling location case to interface to the trackside object controllers and other devices. They are then linked back from trackside to control center with FTN nodes, which is the fixed telecom network, which is the sort of railway bespoke communication network for the entire country. Back at the control center, we have various cubicles linked together by network switches, and we provide links back via the fixed telecom network to the trackside infrastructure. Just to put this into context, pictorial view, an example of a line side location case is shown on the left. We have Frauscher axle counters here, Electrologics object controllers, along with a network switch here. The other two photos on the right, on the middle and the right, show example control center cubicles, which don't look a lot different from necessarily other cubicles you see on the railway or again in other industries. And now I just want to talk a bit about the Atkins signaling method. And the system is made up, as I mentioned, of various different components, and the Atkins signaling method really defines the architecture of that system and how it operates and how we actually design and implement a scheme. So it's a big sort of change from approaches we've had in the past, where every scheme is designed in a sort of bespoke manner, and there's less constraints other than the sort of network rail regulatory standards. Before, people were sort of given a design, they could run free sometimes. They could maybe save a bit of money by saving equipment costs, but then when you're actually looking at the whole picture, if you're going to design every location case, every cubicle in a bespoke manner, that will cost more money in the long run. A sort of analogy for this would be, you buy a car, you want to save a bit of money, you only want 3 wheels, you wouldn't actually save money, it would cost more to get a 3-wheeled car because it would be a different design. Deviations, for this reason, deviations from the Atkins signalling method have to be agreed by the technical authority group for the ASM, to make sure that projects don't just make project-centric decisions which overall would cost money to the business. And there's only one, as I said, there's only one way to approved way to design these schemes. It is to use the Atkins signalling method. The sort of Atkins signalling method on paper consists of a range of manuals, templates, and electronic procedures and tools to help the sort of designers to produce the designs for projects. Going on to the sort of templated design, we have template managers for each individual design, and they're responsible for maintaining and updating these templates as required. We get the templates actually reviewed by the Network Rail Signalling Innovations Group centrally, and we allow projects to configure certain items, which are shown in blue shading on the 2 examples to the right. Examples would be things like project titles and borders and specific numbers, but the sort of core fundamentals of the template remain unchanged. When Network Rail are reviewing templates, or project-specific designs for acceptance, they can realistically only comment on the blue shaded elements because the remaining elements have been agreed centrally. And alterations, again with the rest of the ASM, require permission from the technical authority for the particular template. Just to sort of go through a bit really about the key achievements we've had on the Atkins signalling method and the sort of rollout so far. We started the journey back in 2011 when the agreement was reached with GE for supplying this product to the UK. Development sort of continued then throughout the next few years, with the first project commissioned was Old Oak Common Depot, which is the Crossrail depot. So that was commissioned in, I believe, 2017, 2018. We then moved on to the first UK railway mainline application, which was the phase 0 of the Feltham Area Resignaling project known as Shepperton, and that was commissioned in June 2019. We then swiftly moved on to a much larger project, the Norwich Yarmouth Lowestoft project, which was commissioned in February 2020, so just a few months ago. In terms of product acceptance, we sort of based our first initial work on Old Oak Common, although it wasn't a Network Rail application, so it required different approvals. It did give us a good grounding for moving on to Shepperton, where a specific application safety case was produced for Shepperton, and that then granted us with a sort of trial certificate for use on this project. And that was really one simple interlocking and a MCB CCTV level crossing. We then moved on to Norwich Yarmouth Lowestoft, which was a much larger scheme, but still of a low complexity, and that produced a extended trial certificate for our use on this. As we're now working on Feltham Phase 1, which is a much larger area of the overall Feltham project, we are then looking to gain a generic application safety case from this, and we'll then have a full product approval certificate for future schemes, and we then simply have to look at a gap analysis against any sort of novel requirements on future schemes rather than producing a safety case from scratch. In terms of future projects we're looking at, a lot of our work at the moment is on a very large resignaling scheme, Feltham resignaling, and that's on multiple phases. So we're currently in contract for phases 1 through to 4, and they commission from April next year, and the commissioning of phase 3 and 4 is in December in 2022. We're also working at the moment on the GRIP 4 for East West Rail phase 2, which is a brand new railway across the country, ultimately linking Oxford and Cambridge. And this is phase 2 of that, with phase 1 completed already. That's due to be commissioned in 2024, so that's another good bit of work for implementing the Electrologics Interlocking and ASM. Other opportunities in the future are the final phase of the Feltham scheme, which re-signals the Wokingham signal box area, which is the last bit, and also several standalone level crossing renewals as part of the MASREF Tier 2 framework. So that will be looking at implementing Electrologics as a standalone level crossing rather than a fully integrated signalling system. In terms of what projects are coming next, what developments are coming next, we're currently developing voice over IP telephones, so SPTs, point zone telephones, and this is for implementation on the East West Rail 2 project. The advantage of doing the VoIP telephony means we don't have to rely on, again, separate copper cabling to provide those links back to the signalling centre. It is all via the IP multi-service network. As I touched on the last slide, for standalone level crossings, we're developing what's called level crossing in the box, which is the standalone crossing. So we're developing that for the second phase of Feltham, where we need to stage a level crossing back to an existing signalling centre in advance of the main commissioning. The next bit of development on Feltham phase 2 is then an MCB OD level crossing, which we'll be implementing in April 2022 for the main Feltham phase 2 commissioning. This will be one of the first implementations of the Mark II obstacle detection system, which is due to be trialled only slightly before phase 2 commissioning, I believe, at Nether Poppleton. In terms of after that, future possible developments are potentially IP-enabled barrier machines. So at the moment we have large multi-core cables controlling barrier machines from level crossing location cases. There's potential to actually, again, provide an IP network to these to reduce on cabling, and also IP-enabled signals in the future, which would reduce trackside infrastructure. And again, the emphasis is on making more and more equipment IP-based, and it increases sort of scalability and connectivity. The system is also compatible with ETCS, so looking at integration with radio block centers for any ETCS rollout applications. Thank you very much, and I'm happy to now answer questions. If there's any questions you think about later, my contact details are on this slide, so feel free to drop me an email and I'll be happy to answer. Thank you.
Thank you very much, Peter. That was a very interesting talk, and it covered all aspects of signaling and how we started from mechanical relays and where we're going to go forward in the future. So thank you very much for the talk.
No problem.
For an infrastructure engineer, it was a very insightful talk and a good introduction to railway signaling systems. I've seen a lot of questions are being asked, and for new joiners, on your screen you will see a question tab. So in the question tab, if you have any questions, please type them down and I'll ask them for you on your behalf to Peter. So to begin with, we've got an actually young rail professional who's thinking about a career in the railways, and he's asking, what degree would you need for working on the railway? Do you actually need a degree, or what are the different ways?
To be honest, there's several different ways into the rail industry. I didn't say at the start, but I didn't actually join, although I had a degree, I didn't join on a graduate training scheme. I just joined for a specific assistant engineer role, and that probably might have given me less initial experience sort of in the wider different disciplines, but it gave me more specific experience in railway telecoms. There's now several apprenticeship schemes, especially with the Rail College in Birmingham and Doncaster, which I believe was initially sort of aimed at HS, sort of building up the workforce for HS2, but I think it's been renamed recently to sort of be more general sort of intake for the issue about not having enough railway engineers. So yeah, you could go into it from the apprenticeship route or graduate route, but in terms of qualifications, it depends really on the discipline. So signalling, telecoms are generally electrical based qualifications, whereas civils and PUA would be sort of civil engineering and general engineering sort of backgrounds. So, and then there's project management roles, commercial planning. So really the railway industry employs people from all sort of educational backgrounds really and disciplines.
Thank you. Next up, we've got a question from Mohammed Ismail. He's asking, out of the 8 grip stages you worked in, which stage did you find the most challenging and the most rewarding, and why?
I think that's a combination really. The grip 3 stage, which is generally option selection, where we look at different options for implementing sort of either different technologies or ways of meeting a customer requirement. Grip 3 is really interesting because you get exposure to a lot of the different stakeholders who have an interest in the railway. So it might be the actual route asset manager who owns the railway infrastructure and is responsible for it, and ultimately is then responsible for the budgets for renewing it. So that gives you a lot of exposure to a lot of different stakeholders, and you have a lot of interesting meetings, and you've got to solve quite a lot of problems, but more at a high level. The other interesting sort of stage really is when we get to grip 6 to 8, which is the implementation of the project. So you may have queries back from site, you'll have to spend maybe more time on site looking at problems, and you actually get to see your sort of scheme being sort of built, commissioned, tested and handed back into service. So I think on the whole, my preference has always been the sort of later grip stages really, from a sort of interest point of view. It's just because you get to see something being built and you can see what you contributed to.
Thank you. Our next question is on cybersecurity, and it's from Wendy. So Wendy is asking, are there any cybersecurity concerns with your system? If so, how do you mitigate them?
Yes, as part of the safety case for every project we implement, part of that is a sort of cybersecurity assurance process, and we go through that with Network Rail Telecoms, who look after cybersecurity for all telecom schemes, all signalling schemes, and all of the electrical and SCADA renewals. So we have to satisfy what is a document known as ISA 62443, and that has, I think it's about 50-60 requirements that we have to meet for a project, or if we don't meet them, we have to say why we've not met them and what the sort of mitigation would be. So a lot of them are simple things, such as any unused network ports being disabled, to ensuring that equipment is in access controlled buildings and suitable physical sort of security protection is in place. So that's very important. We have to get sign off for the project, and it will only go ahead if we achieve that sign off. So it's taken more and more seriously as security threats increase with sort of IP connected systems, and general sort of threat levels increasing as hackers get more and more sophisticated.
Thank you. Our next question is from Joy Gray, and it is, what is the role of Atkins to standardize the interlocking system? Do you work with any other companies, Network Rail or TFL?
So was that, sorry, could you just repeat the first bit? Was that what was the rule or role?
The role of Atkins in standardizing the interlocking system.
So we've obviously done a lot of work into standardizing our sort of architecture and our solution. We can't, there isn't really a sort of national standard at the moment for making the architectures any more standardized, other than using sort of good principles that are available. From a sort of data point of view, we produce all the data. We're working towards standard EN 50128 for data production. So that is sort of standard across the piece on sort of interlocking systems going forward. But from a hardware point of view, it's very difficult to standardize when every manufacturer uses different hardware. But the sort of architectures we're producing are fairly constrained due to the sort of nature of the railway. You're always going to have to connect points, connect signals, connect train detection along a sort of long, thin piece of railway. So you'll find that a lot of suppliers' sort of IP solutions will be fairly similar. And as I said earlier, we're working with the Network Rail Signalling Innovations Group. They approve all our templates. And so we do have a sort of level of consistency. We can't just go off and produce something completely different to what's sort of best practice, really.
Thank you very much. Our next question is regarding competition with other companies. So Elliot asks, how does Atkins see itself competing in the future with the Electrologics interlocking against the likes of Siemens WTS interlocking system for large-scale projects?
I think really there's never going to be just one supplier of technology. It would be unwise for Network Rail to sort of have all their eggs in one basket. Siemens are obviously sort of a key competitor to Atkins on a sort of very large scale, and I believe our Electrologics sort of solution with the Atkins signaling method probably complements Siemens system quite well. We're never going to be able to roll it out to everywhere, so I believe there is space for multiple technologies sort of in the railway market, and we really have to put our trust in Network Rail that there'll be a sensible rollout plan to allow multiple suppliers to roll out in different regions as and when required.
Thank you. Our next question is from Louise, and she's asking, is the Atkins signaling model only being used in the southern part of the NR railway systems? Does it interconnect with a new ETCS system in place on Paddington to Reading line?
So at the moment, the rollout has been in specifically the southwest, the Wessex region for the Feltham scheme. We are looking at, we're committed to implementing the solution on East West Railway as well, and we'll be looking at other projects in other regions as our sort of commissioning timeline sort of develops and we commission Feltham. It doesn't interface on the Feltham scheme to the sort of ETCS system, just because of the sort of geographical location of it, but we are looking at the sort of ETCS interface in the future as the sort of demand comes up, really.
Thank you. Our next question is from Febby. So Febby is asking, Atkins is preparing GASC for the Feltham project, but eventually, do you still have to provide a specific applications safety case for each project? And she's got another question. I heard the idea of ETCS level 2 limited supervision. Can you give elaboration on this matter?
So in terms of the first question, from a safety case perspective at the moment, as I said, we've done a specific application safety case for each project. So for Shepperton, Felton Phase 0, and then for Norwich, Yarmouth, Lowestoft. We are planning to prepare a generic application safety case for subsequent phases of Felton. And although I don't work in the safety engineering discipline specifically, I believe there will then just be a gap analysis or an overriding specific application safety case for each project, which would largely reference the generic application safety case and would just include any sort of nuances of the specific project. So there's always going to be some work required, no matter how much is sort of genericized in the GASC. Could you repeat the second question, sorry?
Yes. The second question is, I heard the idea of ETCS level 2 limited supervision. Can you give elaboration on this matter, on ETCS level 2 limited supervision?
Unfortunately, I'm not an ETCS specialist. I have limited knowledge about ETCS other than that there is an interface with Electrologics via for the RBCs. I can, if some contact details are provided, I can seek guidance from one of my colleagues and answer that question. But apologies, I can't provide a answer for that myself.
In that case, I would recommend emailing Peter on his email address that is on the slide. We'll also be sharing that with you after the talk. So please email him if you have any further questions, and he'll get back to you on that. And the next question is from Mohammed Amra. He's asking, with the plans to migrate from GSMR, what is the work Atkins are doing to be prepared for that?
Could you be a bit more specific on plans for, is that for upgrading the GSMR system? If you're able to respond back in the chat, please.
Okay, we'll wait for it. Right, it might be a bit complicated because we've got a lot of different questions. So I might have to ask him, if you can give him a generic answer, otherwise I'll ask him to get in touch with you directly.
Yeah, that's fine. So in terms of GSMR capability with Atkins, we provide a lot of services, and it's generally sort of body shopping of people into Network Rail to provide specialist resources. We don't generally do a lot of sort of GSMR sort of work on project by project basis, other than sort of the interface requirements that are required for, say, a resignaling scheme, so alterations to the GSMR system because of sort of TD stepping changes. We haven't done a lot of, as far as I'm aware, we haven't done a lot of sort of in-house development of solutions with GSMR at the moment. But again, I can speak to colleagues who have been more involved on that side and provide an answer on that.
Thank you. Our next question is from Laura, and the question is, what are the benefits of this technology / method for the operations and maintenance phase of the life cycle? How has it been received?
So the key sort of benefits really are, one of the benefits and one of the things we've tried to do on schemes is actually place location cases at access points along the railway, which provides safe access to the kit. We've been able to do that. Previous technologies have had limits on cable length between line side assets, such as signals and the actual controlling location case. With Electrologics, that limit is increased to over 1 kilometre, up to 1,600 meters for some equipment. So that means we can be a lot more free with where we actually place location cases. And that allows easy maintenance access, which increases safety because you're not having to walk along the track necessarily. However, the primary sort of method of maintaining or faulting the system, we don't really want the maintainer to have to go to the track or to even go to the location case. So because all of the equipment is networked via the MSN network, via IP, we can actually access all of the equipment and monitor the status from the bespoke sort of maintenance system, which is scalable remote condition monitoring system we've developed. So that can all be viewed, for example, from the controlling signal box. And it's only if you couldn't get a sort of conclusive answer to what the problem is, or you couldn't rectify the problem from this system, that you'd actually then have to visit trackside to fix it. We also provide comprehensive logs as part of that system, which can be used to look at trends in any equipment failures. So we do get a lot more data and a lot more detail about the specific fault, and that might then mean that the maintainer has a lot more background to what the fault is before he has to go to site, so he can make sure the most appropriate person attends site. Also with the system, it is a lot more reliable than some previous sort of technologies. Mean time between failures is a lot higher, so the equipment is actually a lot less likely to break. In terms of how it's been received, very good so far on the sort of Feltham scheme. We've been working closely with the maintainer to actually sort of develop the maintenance system, so we've been able to take into account his needs, and we've sort of worked with him post-commissioning to iron out any problems and nuances with the system, and that's sort of been fed back into the development process to sort of help us make a better system for future installations.
Thank you, Peter. Next up, we've got a question from Frank, who's asking, could you please go into a bit more detail regarding level crossing in a box, how it differs from existing crossing management, and how it will, if at all, change the way it's managed when things go wrong?
So in terms of the level crossing in a box, it's essentially taking the Electrologics Vital Logic controller, and it's providing a level crossing solution with it. And to complement that, we utilize new gate barrier machines, which are a sort of upgraded 110 volt barrier machine, which is a lot more reliable than the sort of old SPX machines. The sort of level crossing in a box concept is you can basically buy an off-the-shelf product or off-the-shelf solution, which is the level crossing, and actually apply it to an existing railway with very sort of little, very few configurable items in the crossing. So it makes standardization, makes it sort of cheaper and more efficient to roll out. Some of the advantages are, as with the maintenance system, with new gate barrier machines operating on 110 volts rather than 24 volts means they can be further from the location cases can be further from the actual barrier machine, so they don't necessarily have to be sited at a crossing. The whole level crossing in a box system fits into 3 standard location cases rather than REB, so we don't need the large footprint for an REB and all the domestic power supply requirements and aircon, etc. The barrier machines are networked from a monitoring perspective, so again we can interrogate those for any sort of trends in faults and in predictive maintenance.
Thank you. The next question is from Michael, and he asks, what has been the biggest challenge into getting something novel into safety critical infrastructure?
I think it's very difficult to say the biggest challenge. There's been numerous challenges. I think really it's working with the sort of new concept of software rather than bespoke languages from a data production point of view. So we've basically utilized standard ladder logic for the interlocking data. That has relied on very specific requirements being produced for the interlocking, which have never, although obviously signaling systems rely on requirements, they've never really been written down to a degree that any software they could be implemented in any software language or implemented by any person without a sort of background in railway. So writing those requirements was a hefty task, and it's always a sort of constant learning curve and a constant improvement with those. So that took a lot of time. The other sort of key thing really was product approval, because product approval requirements are generally, it depends on the equipment, and it can depend on the application, and it's not really a hard and fast set of requirements. So we've had to work very closely with the product approval team in Network Rail to define those and to agree them, and then to prove that we meet those requirements. And some of that really couldn't be proven until the first trial system was in service at Shepperton. So it's been a sort of constant learning curve really with that.
Thank you very much, Peter. So how are we doing with time? Are you happy to take one or two more questions?
Yeah, absolutely, that's fine.
Okay. The next question is from Tyson, and the question is, with the move to IP connectivity, is it feasible to maintain physical separation as a security model, or do you see a future where the signaling network, GSMR network, management network, etc., converge?
Yes, that's an interesting one. We've at the moment we are a physically separate network from any other network. We interface to FTN, but we're not part of the FTN network, and we've relied for a lot of our safety case on sort of physical security of our system, and we've looked into sort of remote access into the system, because this is again balancing stakeholder sort of expectations, whereas the maintainer would love to be able to access the system, say from his iPad in his living room. That's caused sort of security threat really, because then connecting into the internet and without sort of suitable firewalls and segregation in place, that's quite difficult. So far we have relied on sort of physical separation, but it's inevitable eventually that networks will converge, and as we are putting more and more services, say on this network, which would normally have been separate, I can see that's where the future is going. I'm not a security specialist, but I imagine there'll be quite a lot of concerns with sort of putting all your eggs in one basket and merging everything together. But I believe it is inevitable, and as this happens, security controls will become more and more sophisticated, and there are more and more checks. But I guess it only takes one incident to then revert back to sort of the old way where everything is separated. So I think that's a sort of tough one to call at the moment, but I don't think anyone really wants to take too many steps at once with this.
Thank you, Peter. Our next question is from Chris, who asks, as a non-technical individual but interested, I'm not quite clear on how the signals are actually controlled from the signaling center. A number of the initial I do not know, so a simple explanation would be appreciated.
So from a perspective of the signals, there's different types of signal, whether they're actually controlled signals or actually automatic. Essentially, as a train approaches a signal, there is a sort of track section. So a train goes past a signal, which may be at green. It would then occupy the track section beyond that signal. The actual interlocking, because it got the track occupied from that section, would communicate to that signal to show a red aspect, so that another train couldn't go into that track section and crash into the train ahead. That doesn't necessarily need any intervention from the actual signaler himself or herself, because it's automatic. It's within its safety logic within the interlocking. Where the signaler does get involved is when a route has to be set. Say a train is going from one station to another location via a set of points. The signaler may have to set that route, and the interlocking would receive that sort of route indication from, or that sort of command from the signaler, and the points would then move to allow that route or that train to proceed along that route. So it really is a bit of manual intervention from the signaler and automatic sort of safety logic within the interlocking itself. There's also sort of automatic route setting hardware and solutions available various control center suppliers that sort of moves to root setting being automatic. And it's not really a sort of simple subject to sort of go through in one or two sentences, really. It's yeah, quite a big subject, but hopefully that does help. And again, if there's any other information, I'm happy to provide in an email or provide any other reference material if required.
Thank you very much. Our next question is from Ben, and the question is, with regard to the line-side ruggedized Cisco IE2000 switches,
Yep.
Is it proposed that they are multi-purpose? That is, are you looking at using them for signaling systems and VoIP telephony? Are there any perceived issues with this? How does this affect the signaling safety case?
We are proposing to use these I2000s for the voice over IP telephony. So rather than providing a separate network, we're utilizing what we're installing as part of the signaling system, and we're just using spare ports on those actual network switches. What, in terms of affecting the safety case of the signaling system, because the safety integrity level for the signaling system is actually within the signaling hardware itself, it does not rely on the network. It doesn't rely on a sort of integrity level of the network. So the network is actually SIL level 0. So adding the VoIP telephony onto this doesn't actually impact the signaling system. It's also, just to note, it's on a separate VLAN from all of the signaling sort of data, and we have a QoS policy which prioritizes the vital signaling data over any other traffic, such as the voice over IP system and any maintenance traffic.
Thank you very much. And the last and the final question is from Simon. So Simon's asking, is it fair to say that traditional signaling discipline is being subsumed into comms/computer/electronic engineering? What future for signaling engineers?
I think that's a valid question, really, because we've traditionally, we say, had operational telecoms, which has generally been providing SPTs, concentrator systems, and sort of long haul links. We then had the signaling discipline, providing interlockings and signals points, etc. And we've then sort of really got a sort of discipline in the middle, which is sort of signaling systems and sort of communication systems, which kind of sort of is a blend of skills. So you now need some signaling knowledge to produce a comms network, and you probably, you need some comms knowledge to sort of design a signaling system. So I don't think it's necessarily taking away the skills of traditional signaling engineers. There's still a lot of work in the sort of interlocking data, or the specifying of the interlocking data, especially at the requirement stage. But I think we are moving away from needing people at the detail, or people sort of on a particular project that have the in-depth knowledge. It's more relying on people with the in-depth signaling knowledge to set the rules and actually audit the sort of process and how the system is designed from a higher level now. And that's especially the case with templated design. And that obviously does produce issues for the future, because if everything is templated, all processes are documented to the nth degree, it allows less flexibility for engineers to actually come and learn the techniques of the sort of junior engineers, which I think is a sort of problem that the industry will need to address.
Thank you very much for that. If anyone's got any further questions, please contact Peter on his work email address. And it's been a really good session, and we are seeing a lot of thanks in the comments section. And thank you very much, Peter.
That's fine. Yeah, glad you enjoyed.
And we look forward to inviting you again soon in the future when things are back to normal, hopefully.
Excellent. Yeah, I look forward to it.
Thank you very much. And thank you all for attending. And we'll hopefully see you soon for the next event. Thank you very much.
Cheers.
Cheers.